National Service Training Center. We will be using this and other facilities within the Ford Engineering and Research Center in Dearborn to acquaint you with important service and technical features of the new 1985 models. For example, Ranger and Bronco 2 models have a new 2.3-liter turbo diesel and 5-speed manual transmission. Electronic multi-port fuel injection has been added to the 2.3-liter overhead cam engine on Ranger models. And there is a new A4LD automatic transmission for all small gas engines. Bronco and F-Series pickups with 5-liter engine are also equipped with a new electronic multi-port fuel injection system. Electronic central fuel injection has been added to the 2.3-liter HSC engine for Tempo and Topaz. An improved performance version called the 2.3 CFI Plus is available on models with the Sports Performance Group option. To learn more about these and other 1985 model features, let's move inside the training center for more detailed review of new and revised components. First, let me remind you that only the most important changes will be covered. For more complete details, refer to specific training program reference books, the 1985 Service Features newspaper, and shop manuals. They provide the know-how to keep you up to speed on servicing 85 models, so you can maintain Ford quality and customer satisfaction. Let's move over now and take a look at that new 2.3-liter turbo diesel engine, which is optional in Ranger and Bronco 2 models. It's an inline 4-cylinder design. The cylinder head is made of aluminum. The block is the deep skirt design with dry cylinder liners. And the crankshaft is supported by 5 main bearings. The turbocharger boosts peak power by about 25% over non-turbo engines, thus making this lightweight, compact diesel a strong performer in Ranger and Bronco 2. Quick starting is assured with an electronically controlled super quick glow plug system and a fuel injection pump with a thermostatically controlled cold start system. There are 2 quiet running cogged or tooth timing belts, one to drive the camshaft and injection pump, the other to drive the 2 silent shafts. The silent shafts function as counterweights, much like balance weights for a wheel and tire, to reduce engine noise and vibrations at medium to high speed, and achieve unusually quiet operation in a 4-cylinder diesel engine. Service procedures are similar to other Ford diesels. Do take a moment, however, to become familiar with the belt timing procedure, which is covered in the 2.3-liter turbo diesel engine training book and is critical to the proper operation of the silent shafts. Here are the only new special tools required. Many of your present diesel engine tools can be used on the new 2.3 engine. That completes our look at the only completely new engine for 1985. But there are several interesting changes that Ford engine engineers have come up with for 1985. This is a fuel injection pump for all 2.4-liter diesels in Continental and Mark 7. The pump features an electronic fuel injection timing advance system. An electronic control assembly in the trunk functions as a fuel flow computer to operate the system. Injection timing is controlled in much the same way as EEC4 changes distributor spark timing. The electronic control module analyzes information from 4 sources: fuel flow at the number 4 injector, crankshaft position, engine coolant temperature, and barometric pressure. Then signals the injection timing advance solenoid valve to open or close a calibrated orifice. An onboard diagnostic connector is used to check injection pump timing. One final point: if a problem develops in the fuel control computer, the turbo overboost light will come on and remain lit. Of course, it will also come on during an overboost condition, but should normally go out when boost pressure drops below 13 psi. Now, I want to show you something really interesting. Another Ford first. It's a two-speed accessory drive system, or TSAD for short. It's available on Mustang Capri models with the 5-liter 4V high-output engine and manual transmission. Basically, the idea is to operate the accessories at half speed above 800 RPM. This reduces engine load and thus conserves horsepower, which in turn improves performance and fuel economy. Note that as with conventional systems, a serpentine belt turns the accessory drive units. A second jackshaft drive belt, however, is also used. It operates the air pump and always runs at full speed. The air pump is mounted to a bracket that also contains an electromechanical clutch, which operates much like an air conditioning compressor clutch. The serpentine belt runs in the clutch pulley. Now, let's see how the system works. This switch will simulate a TSAD control module, which senses a variety of engine operating requirements. Under 800 RPM, or when operating conditions demand it, the control module activates the electromechanical clutch. This electrically locks the serpentine belt pulley and the jack shaft belt pulley together. As you can see by the stripes on the drive belts, they are both turning at the same speed. A one-way clutch on the crankshaft overruns in this mode. Above 800 RPM, the module shuts off current to the electromechanical clutch, which uncouples the two pulleys. The serpentine belt now runs at about half speed. Because the one-way clutch is now locked to the crankshaft, and its pulley is about half the diameter of the crankshaft pulley. No special tools or procedures are required to service the TSAD system. To adjust jackshaft drive belt tension, first loosen 3 bolts on the bracket. Then adjust belt tension. I think you'll agree that the two-speed accessory drive system is a nifty idea. Now, I'd like to show you another feature on this engine, a roller tappet valve train. You'll find roller tappets on Mustang Capri with 5-liter 4V high output and Continental Mark 7 models with base 5-liter CFI engine. The primary advantage of roller tappets is that they improve fuel economy and performance. The roller on the end of the roller tappet rolls over the cam lobe, which generates far less friction. As you can see, roller tappets are longer, which requires a longer tappet boss in the block. So blocks are not interchangeable. The roller tappets are held in alignment to the camshaft lobes with a guide plate, which in turn is retained with a guide plate retainer. The push rods are shorter because of the longer tappets. Here are a couple of additional points you should know. The guide plate must always be installed with the word up facing upward. The rocker arm end of the push rods has a hardened ball with copper plating. A small bracket encircles that end of the push rod as a reminder to install that end upward. Roller tappet distributor gears are machined from hardened steel to be compatible with the billet steel of the camshaft. Don't attempt to use gears designed for other camshafts. Also, the shaft diameter is different for EEC and non-EEC distributors. Always check part number and color code as described in the Engine Admissions Car Reference Book. Now, let's take a look at some other interesting developments, beginning with fuel systems. There are a number of changes in 1985 for both cars and trucks. Here's a brief recap. Electronic fuel injection has replaced the 6149 model feedback carburetor on 2.3-liter high-swirl combustion engines. Fuel metering and related functions are controlled by EEC4. The CFI system is similar to previous CFI systems, except It features a single low-pressure, low-resistance injector and a regulator that maintains fuel supply pressure at about 14.5 psi. Most other Ford injection systems have a pressure of about 39 psi. Fuel is channeled to the injector and surrounds the lower portion of the tip. Excess fuel that doesn't flow through the injector is channeled to the pressure regulator and returned through the fuel return line to the fuel tank at a pressure of 3 to 6 psi. An improved performance version of the base 2.3-liter HSC CFI engine, called the 2.3-liter CFI Plus, is available on Tempo Topaz models with the Sports Performance Group option. The Plus engine uses a performance camshaft, low-restriction air cleaner, and an injector with greater capacity. Be careful not to interchange cylinder heads or intake manifolds of base and Plus engines. They physically fit, but the ports, runners, and combustion chambers are designed differently. Now, we're going to take a look at the first two truck engines equipped with electronic fuel injection. This is the 2.3-liter overhead cam engine used in Ranger and Bronco 2. As you can see, electronic multi-port fuel injection has replaced the YFA carburetor. It is very similar to the EFI used on 1984 2.3 overhead cam car engines, so we won't go into details here, except to note that it also uses EC4. Electronic multi-port fuel injection is also used on the 5-liter engine for Bronco and F-Series trucks. This is a first with Ford V8 engines. Previous systems were the central fuel injection design. Fuel metering to the injectors at each port is controlled by EC4. To achieve optimum performance, the end injectors on each bank fire simultaneously, then the middle two injectors on each bank. The air intake system features a low-restriction air cleaner, a throttle body, an aluminum intake manifold with tuned runners and split plenums, and an aluminum injector manifold with matching split plenums. The cylinder head intake and exhaust ports have been modified to achieve increased flow and improved performance. All in all, this total design package of simultaneous double-fire injection and EC4 electronic engine control makes the 5-liter EFI one of the most sophisticated engines available today. As you can see, fuel injection is big in 1985, but we still have carburetors. So let's see what's new in that area. The fuel inlet needle tip material of YFA carburetors has been changed from Viton to Vernalon, which is more resistant to the ethanol and methanol used in some gasolines. Note that Vernalon tips are pink, while Viton tips are black. Now, let's see what's new with electronic engine controls. For the most part, 1985 is a year of expanded usage and minor modifications. For example, 2.3-liter overhead cam truck engines use an EC4 system. It is similar to the 1984 car engine design as mentioned earlier. New features include control of the converter clutch override solenoid in the new A4LD transmission. EC4 is also used on the 5-liter EFI truck engine. It is very similar to the EC4 system used on 5-liter car engines with central fuel injection. The EC4 system for 2.3-liter HSC engines has been modified to accommodate central fuel injection. New items include an EGR electronic vacuum regulator, low-pressure fuel injector, fuel pump relay, idle speed control actuator with integral tracking switch, canister purge control solenoid, and power steering pressure switch. Steps have been taken to streamline and simplify EC4 diagnosis. Quick tests have been consolidated by use of a new matrix, and pinpoint tests have been reduced from 54 to 43. This new Rotunda MAP BP sensor tester will also help you with EC4 diagnosis. It eliminates the need to substitute components to perform tests. Before we leave engine and related controls, let me point out a change in the universal distributor rotor used in 2.3-liter overhead cam and 5-liter fuel-injected engines. The two rotors are shaped differently, but both have a snout. In 1984, the rotor was attached to the armature with two screws. In 1985, the rotor slips over the distributor shaft and the snout into a slot in the armature. Don't attempt to force it into one of the apparent slots because the cap won't fit properly and indexing will be incorrect. At Product Engineering, they've developed a number of new chassis, suspension, and transmission components. Now, let's look over this new A4LD 4-speed automatic overdrive transmission, which is available in Ranger and Bronco 2. It's the first Ford Motor Company automatic transmission to use electronic controls integrated with the onboard EEC4 system. These controls activate a converter clutch solenoid in the valve body that works in conjunction with the valve body hydraulic shift scheduling to engage and disengage the piston plate clutch in the torque converter. This feature provides better performance and vehicle drivability. The A4LD is a derivative of the C3, and the components rearward of the intermediate drum are similar to the C3 automatic. The forward components are new for the A4LD. As you might suspect, service procedures, tools, and maintenance are very similar to the C3 transmission. Now, let's briefly review another new transmission, the 5-speed overdrive manual transmission, which is used in Ranger and Bronco 2 models. It's fully synchronized in all forward gears, features standard power flow, and has an aluminum case, adapter housing, and covers. A few new tools are required for servicing, but procedures are similar to other manual transmissions. Now, I'd like to show you a couple of revisions to existing transmissions. First, the shift pattern of MTX transmissions has been changed. In 1984, reverse was next to first gear, making it possible to inadvertently select the wrong gear position. In 1985, reverse has been moved down below fifth gear. These are synchronizer blocking ring assemblies from T5 manual transmissions for 1984 and 1985. Note that a fiber insert ring has been added in 1985 to improve durability and give a crisper shift. The shift tower has also been revised to give a shorter throw and crisper shift. A new anti-lock brake system is available on Continental and Mark 7. A sensor and toothed ring assembly at each wheel signals the controller when brake lock is about to occur. The controller signals the valve body, which activates appropriate hydraulic circuits to modulate braking action at each wheel. If a malfunction occurs, the controller automatically deactivates the system, and warning lights signal the driver. Normal power braking continues to occur. Here is an important safety precaution. The hydraulic pump generates pressures of over 2,000 psi in the system. Before opening any hydraulic circuit, relieve the pressure by turning the ignition off and pumping the brake pedal a minimum of 20 times. A rear suspension automatic load leveling system is available on Lincoln, Ford Crown Victoria, and Mercury Grand Marquis. Essentially, it's a modified version of the air ride suspension system introduced in 1984. Except that conventional springs are used along with air shock absorbers. An electrically operated air compressor is located in the trunk, along with a microprocessor and relay. When the rear suspension is lower, the height sensor signals the module and air is directed to the adjustable air shock absorbers to again raise vehicle height. A driver airbag restraint system will be available on a limited number of 1985 Tempo Topaz models. The airbag is designed to provide supplemental protection to that provided by the 3-point seatbelt system. Be sure to review the airbag restraint system training program so you're prepared to diagnose and service the system. The Diversified Products Technical Center has developed many of the electronics for components and systems previously discussed, plus a variety of others. For example, all 1985 trucks with gas engines will be equipped with an extended useful life sensor module. It senses ignition key on time. After 2,000 hours, which is equivalent to 60,000 miles, the sensor activates an emission maintenance warning light on the instrument panel. Electronic digital display for speedometer and odometer functions has been expanded to Thunderbird and Cougar. An optional cluster features 3 separate electronic modules for speedometer, odometer, fuel computer, and tachometer multi-gauge functions. The tachometer features a curved linear bar graph, and the multi-gauge displays coolant temperature, oil pressure, voltage, and fuel level. A mobile telephone system is optional on 1985 Mark 7 and Lincoln Town Car. The system features a remote handset and a microphone in the headliner. The driver receives communications through the radio speakers and talks to the microphone, which allows hand-free operation while driving. You are going to find that our next new product provides a dazzling display of electronics being used to the fullest. A limited number of Mark 7 Comtech models will be built with a variety of high-tech electronics, from which the name computer technology is taken. The centerpiece is this advanced instrument panel and unique steering wheel. A variety of instruments and controls can be activated without removing the hands from the wheel. Note the CRT switch. Depressing it displays the next feature on the screen. You can also depress one of the feature buttons below the screen. The display also contains on-screen buttons in the image area. Additional data can be displayed by simply placing your finger on the image area in front of the on-screen button. This blocks a light beam, and the computer inside senses what button has been selected. As we near the end of this video disc, I'd like to briefly review the features of the new Merkur XR4TI. Its European-inspired design marks it as a true high-performance luxury touring car that's equally at home on the track. It's powered by a turbocharged 2.3-liter overhead cam engine with multi-port fuel injection, EEC4, and electronic boost control up to 15 psi. It's coupled to either a C3 automatic transmission or a Hummer 5-speed overdrive manual. The McPherson strut front suspension features gas-filled shock absorbers, rack and pinion, variable rate power steering, and 10-inch ventilated disc brakes. Independent rear suspension is used with the aluminum differential case mounted to the body, half shafts, direct power to rear wheels with 10-inch drum brakes. This completes our review of 1985 new model features. For complete details on these and many more items, be sure to refer to the reference books for specific vehicle areas.